Ever wondered how the Earth orbits the Sun, how the Moon orbits the Earth, or how anything orbits anything? Well, the answer lies in Kepler's laws. Kepler was a German astronomer, and he had 3 laws of planetary motion. The first law of Kepler says that planets move in elliptical orbits. The second says that planets cover the same area in their orbits in the same amount of time. Thus, the area a planet sweeps across an ellipse is equivalent to any other area it sweeps with the same change in time. The third and final law says that a planet's orbital period is proportional to the size of its orbital or semi-major axis. Perhaps Kepler's laws will become clearer with an example. If we look at Earth, we know Earth orbits the Sun in an elliptical orbit with a semi-major axis is given. Using parameters of the gravitational constant g, the mass of the Sun m, and the semi-major axis a, we can arrive at a familiar answer. 365 days, otherwise known as a year, is the orbital period of Earth. Similarly, consider the fact that the Earth is closest to the Sun every year in January. This distance is called perihelion, and it is given. Conversely, the farthest Earth gets from the Sun is aphelion, and it corresponds to a distance on the screen. A cool thing about the orbits of planetary bodies is that the total energy stays the same throughout the orbit. Thus, kinetic energy plus potential energy is constant. This must mean that we are traveling faster when we are closest to the Sun in order to sweep out the same area compared to if we were farther. And I know all of this might seem really abstract and far away, but Kepler's laws can be very useful. For instance, NASA launched its first planetary defense mission this year called DART, or the Double Asteroid Redirection Test. With DART, NASA wanted to alter the orbit of the asteroid Dimorphos to show that we could alter the orbits of asteroids that pose a threat to Earth. We don't want to go out like the dinos, do we? But how can we change the orbit to be exactly what we want, or exactly not what we want? With Kepler's laws, of course. Knowing how much energy is lost and how much is transferred to the orbit of the asteroid, we can calculate a new orbit, which will adhere to orbital mechanics and Kepler's laws in much of the same way planets do. In fact, telescopes around the world have detected such a change in the orbit of Dimorphos, shortening the 11-hour and 55-minute orbit by 32 minutes. Incredible! Space is governed by orbital mechanics, and the key to unlocking how bodies move around each other is Kepler's laws. So, the next time you ask those questions, how does the Earth orbit the Sun? How does the Moon orbit the Earth? How does anything orbit anything? I hope you think about Kepler.